I think it's okay. So that's the thing. So we are considering here the length for epsilon and delta. So if you consider that in case of your function of single variable, then also you are getting that your epsilon delta. That epsilon delta is not depends upon your x, not depends upon your y. That depends upon that defines you the length between the point and the point, arbitrary point that you are choosing surrounded by that point. Okay. So therefore epsilon and delta is not defines on any plane, depends on, means it's not existing, means not in the plane x and y, so it depends on your x and y. It is a length you are choosing, that maybe as you know that delta can be your sometimes half and more than less of that. Okay.
Sir, in the second slide, can you please explain the last equal to part in the last step?
This one, this
Yes,
equal
sir.
to,
It is equal to. Yes, sir. In the
equal
last.
to, equal to is considered to be, if suppose your x equals to 0, then you are getting that under root of y square and under root of y square, that time you can get it. Okay, because we are considering here x square plus y square, sorry, x and y is tends to your 0 0, so it can possible that the value of your x is equal to 0, and then you are considering that y, that means you are choosing that the y axis, that time you have it to be equals. Okay, even though if you don't consider this equal to, then also it is not fact, it's not possible.
Okay. Okay, sir. Thank
Okay. So this is the one way we can choose, we can test. Another way we can test the existence, but there is some particular types we can define. So that portion here. No, so we consider the function, but we are getting that f of xy. So f of xy means x and y is an ordinate and it is from your R2. So f is a function which is defined of your R2. We are leaving the origin outside, and that goes to your R. So we are considering the function. Then we know what it happens to be if we consider that limit your x tends to 0, f of x equals to your L, for some value of your x, and this x is not your R, belongs to R, that x is belongs to your R2. Okay, that means x has its component, we can choose to be your x and y. Okay. Then as you know that by the epsilon delta definition, that means what? That is mod of L fx minus L is less than epsilon when your mod x is less than delta for all those x satisfying this. But we can also have, if you have for every unit vector, if you have the unit vector, so for unit vector we have vector, suppose it to be denoted by v, then, and that v also belongs to your R2 of course, because f is defined on there, then limit can be shifted to there, f of tv, which is equals to your also L. Because if this will happen, that means that if the limit exists, then we can say this one. And because this criteria and this criteria is quite same, means is same, because if you consider that for some epsilon greater than 0, then delta greater than 0, then for that epsilon and delta we have all those v which are satisfying with tv, that is 0 less than mod of tv less than your delta, that is always to be positive because mod value we are considering for all those tv, it will imply that mod of ftv minus L is your less than epsilon by this definition. Now v is your unit vector, so we can take that 0 less than t less than delta. So for all those t, we can have tv minus L is less than epsilon. So that gives you that if as t tends to 0 plus f of tv, it comes to be equals to your L. We can have some problem that we can verify this result. Problem number 2 is that if you consider so that the limit x square y square does not exist. So if we can show that by that particular as t tends to 0, f of tv is depends upon your different path. So that means for different vector, unit vector, if you are choosing, and that gives you some different values, then you can say that it will does not exist. You can take that one also, that by considering any path. I think this one you can take a test of that. So if you consider is a unit vector. So unit vector means what? It's a thing mod of, if we consider that x is equal to your 1, or we can say that mod of v, that we consider therein, mod of v equals to 1. That means you are considering a circle, unit circle surrounded by the origin. So all those points surrounded by this origin. So therefore we can take the points along your x-axis and y-axis also that tends towards your origin. Besides that, we can take any other points from here which has your passes through your, means from that point comes to the origin. So for that, if you are choosing v, if you are choosing v equals to your e1 means if you choose the point from your 1 0, and that gives you the on x-axis. Then you have that f of tv, it comes to, that is 1 0, so that comes to your t square by t square, which is equals to 1. So that the limit as t tends to 0 plus f of tv is equal to your 1. But if you choose that v equals to your e2, that is your 0 1, then you have that f of, or we can choose that v dashed, tv dashed equals to, it's your something tq, that is t square, which is equals to t. Now as t tends to 0 plus, this tends to 0. So therefore for different unit vector, we get different values. So does not exist.
So in previous slide, how we have
Okay.
taken mod x equals to 1,
What we have taken?
mod x equals to 1.
No, no, no.
Why?
Actually, we are not taking this one. I am saying you that you are considering that unit vector. Unit vector means all those points on this circle, which has its, if you are considering that xy plane. So v has its components, suppose x and y. Then your x square plus y square equals to 0. X square plus y square equals to, sorry, 1. And that x or v, whichever you represent by, that has its component x and y. So that has its component x and y. So unit vector means all those points which are lying on this circle, that is x square plus y square equals to 1. So one of the vector we can consider on x axis, another vector we can consider on your y-axis. So by that represented, so mod x equals to 1 we can consider, or we have represented that mod v equals to 1. These are the two things that we can say it to be, or it's better to remove this one because we have taken this one. It is good.
How we are using this? What is the logic behind this problem? I'm not able to get it. The logic.
Logic means what? We are instead of considering that the path we are choosing, that is y equals to mx, y equals to mx square, y equals to mx cube, like those paths, rather than if we consider like this way, that means from any point to your the limiting point that has your ab, if you move along your unit vector, then it transforms to a parametric limit. Okay, you can see that we are choosing here that t of v. So t is considered to be some scalar quantity multiplied with that unit vector. So if this one is exist, so this one exist means mod of fx minus L is less than epsilon for all those x is mod x is less than your delta. So that fx, if you replaced by your f of tv, L is the same value we are getting for all those tv satisfying less than epsilon. Here x is your represented by your tv, so that is mod of tv is less than delta. Now if you consider that v is your unit vector, so that comes to be t is greater than 0 and less than delta. Mod t means it is positive, always considered to be. So that means that comes to a single limit, single variable limit. We are transforming that double limit to a single variable, that scalar quantity.
Okay,
Okay.
sir.
Sir, in this problem,
Can you
we have only in the x in the terms of x, but in the next problem it is x comma y is there, na sir?
No, no,
So,
no. That is not x. That x is your having two component x and y. Okay. That x is a member of your R2. X is an element of your R2. A member of a plane.
sir, one
Okay.
show that slide sir, once.
Is the slide is not visible?
four, sir, four
F
visual,
of
sir.
x is equal to L. This now it's fine, sir. Sir, this f of tv is equal to t square by t square is equal to 1. How is that?
You just replace that your what is TV? TV is comes to your t, and this is your t into 0, that is t comma 0. So if you replace x for your t and y for your 0, that comes to t square by t square.
Okay, okay, sir.
Okay. Similarly,
Yes,
if you
sir.
consider
First
v
we
dash,
accept
yes,
y
yes.
axis.
What is? First one is your x-axis. Second one we are considering that is of your y-axis. That is of your.
And sir, one thing, can you show graphically like how the unit vector is approaching the limit, actually approaching the L? So that then it will be clear, na sir? So
Actually, how could I show? Then we have to draw the graph. What that graph
Sir, but
means.
here once that v is equal to L1 is equal to 1 comma 0 and 0 comma 1, that will be clear means the problem gets easy, sir. But how that approach is we
How
can't.
approach is, you just see what I am said, that mod v equals to 1. Mod v equals to 1 means it gives you a circle, because mod v means you have the component x and y. So mod of v means under root of x square plus y square. So that is x square plus y square equals to 1. So we are considering all the points instead of any points in between, that of from origin to that and the boundary of the circle. If you just consider all the points on this one, and then you are tending towards your origin. Okay, so now for here we are considering the point on this point, that is your v dash, which has its component your 0 comma 1. You are considering here the vector v, which has its component your 1 comma 0. Okay, so these two path we are
Okay.
choosing by considering this. Now if you are getting the for these two are same, you can choose the negative vector that also has its modulus 1. You can take that v double dashed, which is also 0 minus 1. Then also you can verify by that we are getting the different value or the same. If all these four gives you the same value, you just take any other vector which is in between of your v and v dash. Then also we can, because what is happening in this case, you are shifting that limit to the single variable, and that is easier to understand and as well as to evaluate whether it is what will be the value of that limit.
So 0 comma minus 1 change na sir.
Yes.
0 comma minus 1.
0 comma minus 1 will change. Okay.
Sir, by को upon y square तो -1 ना sir.
By you want to consider that 0 comma minus 1, 0 comma minus 1. Okay, so that comes to it's changed. The limit does not exist actually. So we can we are getting the difference in of your 1 0 and 0 1. So why we are going to change that one? We are not showing that the limit exists. Okay, so
Yes.
that criteria, it shows that if this one is exist, then this one is exist. If this will not be exist, then this limit will not be exist. Okay, so that limit is just breaking into and come to the single variable instead of your multiple variable. That's the thing we have done. Means it has been done. Okay.
Sir, here's a t cube by t square equal to 1.
T cube by t square.
Sir, on this slide, sir, in this slide. Yes, sir, in this slide, sir. T cube by t square equal to 1. FTB equal to t cube by t square.
ना
No.
t square by t. Y is
T
equal to
square
0
by
ना.
t square. Y
Okay,
is
okay,
0.
okay, sir. Okay, sir, okay, sir.
So that portion is of your limit. Now in case of your continuity, we just solve one problem for continuity.
Sir, please show the last slide once. Sir.
Again.
Again, one. Thank you, sir.
So problem 3. We consider the function f maps R2 to R, and it is defined by f of x. It is equal to square divided by for x. We have to show that f is continuous. So that f is continuous at is this. So we can choose that of your epsilon delta. So we have to show that that fx minus 0 is less than epsilon for all those x and y which are close to your 0 0. So for that we are taking this xy square and that's enough. If you choose that is equals to your mod x mod y square divided by this, we can write it to be mod x. Okay, that mod x is equal to your x and y. Now this one is less than equals to, you have mod x cube, sorry, this is mod x square because x square plus y square, so mod x square, which comes to your mod x. So as if you take that mod x is less than your epsilon, so we can have that the points which are very close to your origin, and in this case we can take that epsilon is equal to your delta. So that shows that the function is your continuous at the point origin. Even though the function is of your rational function and the function is continuous, it is defined at the point x equals to 0 separately. So we can say that the function is also continuous because rational function is the division of two polynomial function. Polynomial functions are continuous everywhere, and so these two functions are continuous everywhere except at origin, but origin we have tested, that is your continuous. So we can say that it's a function which is your continuous for all values of x belongs to R2. So therefore f is continuous for all x belongs to R2. Okay. Now,
Sir, how can I write x square plus y square is equal to mod x square?
is this one x square actually your mod x mod of xy minus, there is a distance between 2 points I want to mean by that, so that is your mod of it's not, the distance between 2 points is your x square plus y square. So if you have that x square, so it's better to represent that one by v. I'm writing that. So x square plus y square, its whole square, it comes to x square plus y square, so that is your mod x whole square, mod x whole square. Okay. So that x has its component x and y, so you're getting that this comes to your mod x square. Is it now this mod x is of course your less than x square plus y square, so therefore we are taking that less than equals to, and mod y square is of course your less than or equals to your x square plus y square. So therefore that gives you 3 means mod x, 3 mod x, so that is your mod x cube by x square, so that means mod x is tends to 0. So therefore when x is very close to your origin, all those points will satisfy that f of x.
Sir, here can we use that vector method, unit vector method?
You can use that. You can use that. But the thing is, once you are considering by this one, so just you have to replace that x is by your TV. Okay.
So can you please explain by vector method?
So then I have to write it down. So we have f of x, that is TV. So for that we have to choose here okay, f of TV minus 0, that is comes to this one, which is your mod of is tx and ty. Square, that is square x square plus y square, mod of this. Now we do not know what that x and y is. It's not always to be 0 1, it's not always to be 1 0. It can be some values for your x and y for which we are getting to be equals to your 1, that is x equals to 1 by root 2, y equals to 1 by root 2. So then half and half plus gives you that 1. So the t square will cancel out, then you have that the expression t. Now we are considering that t is here always positive as t tends to 0 plus, so we have then the remaining expression, that is x y square by x square plus y square. Now as this your t tends to 0 plus, so that expression will goes to 0. So therefore we can say that this value is very close to, means we can show from here that is t is less than your delta, then for those delta we can define that epsilon is, so therefore mod of tv will less than epsilon. Okay, so what I am saying that the result, you no need to be fair about this, ki if this result will hold for epsilon delta, that result will also be hold for your that t vector. You just replace that that capital X wherever you have that by your tv, then you can get this one. It must be so. I'll give you the result. Okay. The last problem I am giving you, I don't have the time too much, so that is problem number 4 that you can solve, I think. So consider the following relation. Consider following relation, that is x square x square plus 6 and xp square plus 2y square plus 2 minus. So the value we can choose at the point, then find your ux, uy, vx and vy at the point instead of 1, 2, 3 and 4, and that it should be mentioned that x, y, u, v equals to this one. At this point, you have to find out ux, uy, vx, vy. This is the these are the two functions which are given in the form of your implicit of your x and y and u, v are related by. Then both of equations you have to differentiate with respect to x and y because they are differentiable function. They are all the polynomial function. So differentiate with respect to x and y, you will get two equations of your ux vx and uy vy. Therefrom you can find out ux and vx. And similarly you differentiate with respect to y, both the functions, you will get the relation between uy vy, and then solve those two relation, you will get that uy vy. I think this you can solve. And the answer are written here, just verify, maybe I wrong. It is 3 by 4 uy is to 1 by 4 vx minus 23 by 4 by comes to 11 by 4. That's all. Then after, if you want, then we can solve. So you have done that tangent, how to find out the partial differentiation and what it represented by.
Yes, sir. Partial derivative complete.
Partial derivative
Yes,
completed.
sir.
So how do you compute that partial differentiation? I'm just giving you that idea, and it will give you how to compute the tangent plane. Do you know that how to? It has been done that how to construct, means how to find out the equation of the tangent plane.
No, sir. Only
Not,
partial
not
derivative.
yet.
Okay, so I'm just trying to give you that idea geometrically. So we consider a surface on there.
Please explain Young's theorem 1.
Which one?
Young's theorem.
Young's theorem. Young's theorem is what you have the partial differentiation. Whenever we are considering that of your mixed partial differential, then what will happen that it will not be always your equal. So if it is you're not equal, then there are means actually it's not equal because of some certain criteria, and the criteria is defined on your continuity. Okay, that is the partial derivative should we have to be continuously exist at that particular point. It's not that the in the neighborhood of that point it will not be considered. So at that particular point the functions partial differentiation are your exist, then we can think of that the what is called the mixed differential, mixed partial derivatives are your exist and equal at that particular point. That idea can also be extended to your what is called the total differential. Okay, so mhm.
Sir, if the function is not continuous at that particular point, then fxy and fyx will not exist.
No, not the function, the partial derivative of the function, that is first order partial derivative, fx, fy at that particular point are not continuous, then we could not be said about that the functions mixed differential area exist.
So please explain by an example or
Okay, so I will explain this fact by an example in the next class. Okay.
Okay, sir.
Okay. So I am concluding here, and I am not going to this one. So this portion I will be done in the next class also. Okay. So just you wait. I just take your attendance. And there are the examples actually through which we can show this, that it will not be continuous, or so it is not equal, being not continuity. Okay, I will explain it by example. Okay, so we are concluding here now.